So day 2, solving equations and literals, the same thing that we were doing on day 1. We're just going to get a little bit more difficult. So just remember we looked at 3 different types of equations. 1, an equation with no equal sign. This would not be called an equation, therefore it's an expression. Here we have an equal sign, so this would be an equation that can be solved. I only have one letter, so I'm going to solve for x. Here, I have an equation, but I have a ton of letters. Remember in this one, letters, variables, I have to be told which variable to solve for before I can continue. So let's do these real quick. Let's start with this here. The first thing we're going to do is parentheses. So 2 times 5, 2 times negative m, 6 times z, and 6 times negative m. I'm going to combine like terms. I have m's that are exactly alike, negative 2 minus 6. I have z, no other one to combine, and I have this number that has an implied positive in front of it. This next equation, I have an equal sign. I'm going to draw the line down. I see that I have a variable of x, and that's the only variable, so I'm going to solve for x. I'm going to start by distributing, doing my parentheses. I'm going to combine like terms. The 5 plus 2 gives me 7x. The negative 10 minus 3 gives me negative 13. I'm going to add or subtract any terms. In this case, I'm going to add 13 to both sides. Negative 13 plus 13 is 0. This will give me 45. Divide both sides by 7. And my answer will be x equals 45 over 7. Should have talked about this in class, about how to check that with your calculator. If I wanted to by hand, I would take this 45 over 7, plug it in here, and make sure that this side, with those plugged in, gives me 32. Okay, now I'm over here, I'm going to solve for L. This is really kind of ugly. So the first thing I just want to talk about is this says t equals 2 times pi times the square root of L over g. Well, here's my L inside. Okay, so I'm going to isolate everything, and since 2 and pi are connected by multiplication, I'm actually going to divide both sides by 2 pi. So I'm going to get t over 2 pi equals the square root of L over g. The problem I now have is that L is stuck underneath this square root. To get rid of a square root, we are going to square both sides. Okay? And if you remember, the squared, if it's attached to this parenthesis, will go to each individual factor inside. So what I'm going to get is I'm going to get t squared over 2 squared pi squared. Equals the square root, whoops, no square root because I squared. So this squared and the square root will cancel each other out, and I will just have L over g. I'm still solving for L, so I need to get rid of this g. The g is connected to the L here with division. This is L divided by g. So to get rid of the g, I'm actually going to multiply this whole side by g. I'm going to multiply this whole side by g. The g and the g will cancel. One's in the numerator, one's in the denominator. And what I have left on the left side is g over 1 times t squared over 2 squared pi squared. So top times top would be g times t squared over 2 squared pi squared equals L. Solve the following equation. A equals v sub f squared minus v sub I squared divided by 2 delta d. For each of the following variables, we're going to solve for delta d and we're going to solve for v sub f. In this equation, v sub f and v sub I are different variables. It's like saying the velocity of the fall minus the velocity of the initial, whatever. But they're two separate variables, so those subs stay with the variable. So we're going to start by solving for delta d. So A equals v sub f squared minus v sub I squared all over 2 delta d. So my v sub f is, we're doing delta d first. My delta d is in the denominator, okay? I hate fractions. Actually, they're one of my favorite things, but I know they're one of y'all's least favorite things. So let's get rid of the fraction first. What we're going to do is we're going to put this side over 1. I can create a fraction on this side. I already have a fraction on this side, so the easiest way now is to cross multiply, and it will get rid of the whole fraction. So I'm going to cross multiply from top to bottom here, and I get a times 2 delta d equals top to bottom here, or bottom to top, doesn't matter. 1 times that is just going to give me that. So I have v sub f squared minus v sub I squared. Now here's my delta d, and this whole thing is one term. Remember, there's no addition or subtraction, which is going to change this term. So I really have a times 2 times delta d. These two things are connected to the delta d by multiplication. So very easily, I can now just divide out the a times 2. But I have to do it on the right side also. The a over a will give me 1, the 2 over 2 will give me 1, so I'm left with delta d equals v sub f squared minus v sub I squared over, and I'm just going to reverse the order of these. We always put the number in front of the letter, so I'm going to make it over 2 times a, not a times 2, and I would be done. Now let's solve for v sub f. So I'm going to rewrite the equation, v sub f squared minus v sub I squared all over 2 delta d. Again, I don't like the fraction, so I'm going to put a over 1 and I'm going to cross multiply. So a times 2 delta d is going to give me again a times 2 delta d equals that cross multiplication. V sub f squared minus v sub I squared. I'm solving for v sub f, this term right here. Let me go ahead and circle it. I want v sub f, and actually I wanted that to be in a different color, but that's okay. So I need to get rid of this term. The v sub f squared and the v sub I squared are connected by this subtraction right here. These are two separate terms, so I'm going to add this term over to this side. So I'm going to add v sub I squared to both sides of the equation. Now over here, the v sub I squared and the negative v sub I squared cancel to 0, so what I'm left with is v sub f squared. And if you remember, I have two terms here. I have this term plus this term. These terms are not like terms, so they have to stay separate. So I'm going to put the number in front. I'm going to get 2a delta d plus v sub I squared. Now the last thing is v sub f is not alone. It has this little squared guy on it. I don't want a squared, I'm solving for v sub f, not v sub f squared. So to separate the squared away, I do the opposite of squared, which is square root. So I'm going to take the square root of both sides, and I'm going to end up with the square root of 2a delta d plus v sub I squared equals v sub f. Now, the one thing I do want you to know is I cannot go ahead and cancel this squared and square root because these two terms are stuck together. And unless I can square root the whole thing, I can't square root one term. So this square root is over both of those terms. On this page, I'd like you to copy this down. I'd like you to solve this on your own, and then take the pause off of your computer and see if you did it right. So if you follow this work, run you through it real quick. I'm solving for d, which is down here. So I don't like the fraction, so I'm going to multiply the right. So the top times the top, the bottom times the bottom, and I end up at sub 2. I'm going to cross multiply because I don't like this fraction. So I get top times the bottom, fg times d squared, 1 times the top, which would give me this. I'm solving for d squared, so I'm going to divide out this f sub g, both sides. This becomes 1, and I'm left with this on this side. I'm solving for d. Right now, I would have d squared under here. In order to get rid of the squared, I do the opposite, which is square root. So I'm going to square root both sides, and I end up with the square root and the squared canceling to d, and I have the square root of all of this stuff underneath. This is another reason why literals are so important. Sometimes you're given a crazy equation like this and information to plug in. Using the equation 1 over f equals 1 over d1 plus 1 over d0, sorry, I think that's an I, when the distance to the image, d sub I, is 20 centimeters, and the distance to the object, d sub O, is 30 centimeters, the focal length of the mirror is how many centimeters? F would be the focal length. So in other words, this is telling me to solve for f. So you should be taking notes, so you need to pause your computer and copy down this page, the chart, and the word problem. After you do that, let's see. What are we given? We are given that d sub I is 20. D sub I is 20 centimeters. We are also given that d sub O is 30 centimeters. We're given a formula. 1 over f equals 1 over d sub I plus 1 over d sub O. And we're going to substitute these. 20 in for d sub I, 30 in for d sub O. So I'm going to get 1 over f equals 1 over 20 plus 1 over 30. If I add these together, I'm going to get 1 over f, and let's just go ahead and do this over here in the solution. 1 over f equals 3 over 60 plus 2 over 60. So 1 over f equals 5 over 60. I don't like the fractions, so I'm going to cross multiply. Bottom times top, f times 5 would give me 5f, and 1 times 60 would give me 60. I'm solving for f, just like my directions set up here, solving for f. So I'm going to divide both sides by 5, and I get f equals 12. But remember, my answer has to have units when it's in a word problem, so my answer would be 12 centimeters.